Perfect. Guys, you're welcome to this our Saturday workshop session here at SolarVista Tech. And as usual, we always bring you this session so that you upskill yourself, so that you learn, so that keep on building your career, be it in cloud, be it in data science, machine learning, AI, be it in cybersecurity, right? And so today is one of those occasions, and we've decided that today, you know what, today we're bringing something from the MLOps, right, perspective. And so today we're going to look at how you can handle code, you know, and particularly, uh, pushing models to the cloud, particularly, right? And so our session today is going to be led by Mr. Bestman Ezekwu, right? Hope I'm pronouncing it well. If not, please kindly help me, right? So, sir, we are happy to have you today during this session where we are going to dive deep into building.
Hello.
Okay, yeah. So I'm back. I'm back. I'm back. So I was saying that we are happy to have you today, right? Today's session where we are going to have you take us on this amazing project session. Like I was saying, we are going to look at how you can move from code to production, with the portfolio maximizer project, right? And as usual, this is a fully hands-on project session. And we want to let you guys get ready, get set. And before we get started, I am going to drop the project repo. I just dropped it. It's still in the chat, right? You can check it up, fork it, and we're going to follow through, that project repo to implement this project, right? On that note, sir, we want to welcome you and welcome Sir Bestman.
All right. Thank you. Thank you, Eric, for that introduction. I don't know if you can hear me. Maybe show my mic. Can you hear me,
Yes,
sir? Okay. Thank you. Thank you, everyone. I'm happy to be
yes.
here. I see some of
Yeah,
my
probably
old
you can start.
classmates.
Yeah, you can start by introducing yourself so that the community should know you, right? I didn't want to
Okay.
start because there's a lot that you are doing that I don't know where I don't want
Uh,
to miss out something,
okay.
right? There's a lot.
All right.
Yeah.
I have a
So
slide. Okay. So I am Bestman Ezekwu. I am a public servant. However, this is my side hustle, side project. And I'm in this presentation today to see how we can also build skills, inspire other people, younger ones, those within Africa and outside Africa to do stuff, become innovative and move with the times. So that's on that. I haven't said that. I have a slide prepared for this presentation. So I go to the next slide, which is what's about the project? Why am I engaging in this? So we have people do trade manual forecasting. They use trade signals. They involve a lot of people and teams. This is quite different because this project it doesn't require human intervention from the start to the finish. The way I'm designing it, it's highly complex. It's going to be machine taking in the data, determining the signal, making trade, and keeping your cash. It's more like you just send the autonomous machine off and you just go have a tea and come back with your profits. So it's full stack, automated, AI integrated. And having said that, it has the advantage of giving faster decision because humans are not involved in the loop, and it's auditable. It's not there. It doesn't have emotions. It works with red with data. For my background, I'm a data scientist. I have a background in my first degree is in political science. I have a master's in defense studies. I have another master's in data science and statistics. So I have an art background and I'm doing statistics and maths and computer science. So just to let others know, I'm not in finance, and that's why I'm not interested in the trading techniques. I'm interested in using machines to do those for me and using quantitative processes to audit the process. Just to tell you that you don't need to be in the field to leverage on that field. Data is data. They all have statistics inherent in them. So having said that, I don't know if which of my slide you're saying. Okay. So the project objective, end-to-end, extract, transform and load, then I'll focus signal routing execution. And it's like I say, without any human interference. Why I'm not just going to let it go on the free ride. There are ways to monitor this, which I will show as we go on. I'll just do the quick video slide, then I'll go into my repo and start and showing what I want to show. So this slide is just to give an overview, if you can read. So when because the project is more than 100,000 lines of code, so it might be difficult to just go through. So it's good to give this high level introduction. So I haven't said that. Like I said, this project is live. As I'm talking to you, it keeps changing. If you go to the repo and check, I just did some commit 2 minutes ago. So by the time you check this project in 1 week, it has moved on. It started from phase 1 and it's actually in phase 10 now. That's almost 100%. So I'm in the stage of optimizing it, and I'm already making profits and have a win rate of 1.7. Made some profit with the Yahoo Finance that I'm using, and I'm still optimizing it. For now, the strategy is working. I want to optimize the models. You can see we have models here. We have Sarima's model, which is seasonal to regressive integrated moving average with exogenous model. This is the time series based model. I have hybrid and have other. I don't have an employee, so I have to integrate other smart and libraries like OpenClaw for orchestration and for monitoring. It's Those are my employee. My employees are machines that check the health project, that help me do runs, that help me search for data, and even give me audit reports and send me signals. So machines work for me, not human beings. So I have employees OpenClaw. So just for you to know. Yeah. So this is just, I don't know if you can see my screen, architecture. You can see that it's, I get the raw data, do the ETL, extract, transform load, clean it up, pass it to the model, make some inference, then using some quantitative measures, I generate what is signal from the data, then I put a trade and then pack out the profit. So that is it, it's full stack. So this is just high level. We're going to go into the details in a moment. Okay. So in this project, you're going to make a lot of decisions, not just DevOps, it's not just statistics. It also has to do with architectural design, parametric and decisions. Like I'm using Parquet. I'm not using CSV5 for my data. I'm using Parquet. I'm using my database. I'm using SQLite. I'm using Prometheus for logs. I'm using Grafana for visualization. So I'm using since the system is such that it has to read the outcome of each run, and pass it to the models. It's self-developing. So I have what they call the JavaScript update notation line to enable the machine pick up data itself and self-correct. And these are architectural decisions you have to make. Why I'm using Parquet, because Parquet, unlike CSV, is faster. It is column search, it's not row search. And these are one of the things you want to know when you're working with data. In finance, every second matters. You can have a signal in by 1200, by 1201, it has changed. So you need to have a data pipeline that is very fast. So your solution has to be tailored to what you're doing. And that is one thing you must know. And that's why I'm using this. So I'm going to do some quick runs during the process. And I know this is finance. Every error will make you get into losses. So I have a strict integrity check to make sure that the system doesn't fool me. It doesn't hallucinate. So I have a schema design that audits what the machine is doing. And if it's doing something that is not expected, it's going to run indicate a failure. So there's integrity check inbuilt there. You see it in the repo. So looking at the forecasting aspects, I'm using time forecasting models. I talked about the seasonal to regressive integrated moving average exogenous model. This is, if you are within the time series, you know this. Also about the GAC for volatility and the spectral autoregressive uh, model, singular spectral analysis. This is also another type of time series model. Also using the multivariate singular spectral analysis reinforcement learning. This is time series model as well as self-learning model like this MMSSL, multivariate singular spectral analysis with reinforcement learning. It's self-correct itself. But all of this, there's an assemble model where each of these models compete for which we going to decide what is the signal to be used for trade. So it's based on their performance. It is performance driven. The model don't just give me output; they compete on the data point, and based on the performance of each, it is given a weight, and that weight will determine it's going to be part of those that will be selected for determining the signal. So it is competitive among themselves. And I have more than 2,000 test unit tests to verify each phase, each model in this pipeline. So unit testing is very critical for this. You see it in the code as well. Okay. So orchestration, the process of picking up the data, extracting it, whether it's from a broker in the future, whether I integrate a broker. For now, I'm using open source data like Yahoo Finance, C-Trader, and the rest. Um, that process of extraction, transformation, loading, pushing into the next phase for forecasting, and and pushing to the next phase of signal generation, and also pushing to the next phase of determining what is the quantitative values using. It is a quantitative modeling system, so there are quantitative metrics that each signal must pass before they can be deemed to be a signal, whether it's going to be a buy, sell, or hold signal. All those modeling process has to be orchestrated, not by me, because I'm a government worker, I'm at work. So I want to have this system run without me. That's the idea. And that's why it's really complex because it involves a lot of things running that I am not dependent on. And it has asymmetric win. I just have to fail a number of times. Once I get it once and that's all, it's just going to work without me. And I can say I'm already making some positive wins. Like I said, 1.7 for every trade. I have almost 40% of the time I'm going to win. So it's on a positive trend at the moment. So there's a run loop, but for automating tasks, I use OpenClaw. I use cron jobs as well. I'm not using Apache um, run because I'm using my own self-built orchestrators. That tests for if you go to the repo, you see to test different metrics to do an ETL, to check the model performance, to check if there's a model drift, to check if there's a regime shift, to do if there's a new trade start in a day. And there are 22 of these kind of jobs that human beings should normally do, and machines are doing it. And that's also something to tell that these days machines are going to replace a lot of human beings, and the machines is what does the job for me. So talking about production gates, I have layered it out. I'm not just moving blindly. I have my timelines and milestones to achieve as I move forward in this project. And I have fail-safe systems as well and human review to make sure that what I'm building is in line, and I have audit systems as well. Okay, so talking about observability, I'm going to look at the logs, the health of my system, my running system, the health of the data itself. I have visualization to make analysis. I have and I have a way of passing this thing to me. They actually send me message through WhatsApp if I'm at work, to Telegram, and so I can be off my system anywhere in the world and I still get updates on my project if it has failed, if it's running, or if it's making profit. That is also done. So I think now I'm going to do I'm going to go straight back into my project to see if I can do a small demo. Just give you some, let me change the screen. If I get back there. So I'm going to change the screen. Okay. So if you can see my screen, okay, I'm just going to take this out. Okay. Hello, can you see my screen? Hello. Can you see my screen? Can I get
No.
feedback? Let me be sure.
I think it's
Okay.
yes. Yeah.
Okay. Okay. So
Yeah.
let me start. This session is for DevOps, it's for data scientists, it's for newbies that want to start running stuff. So I'm just going to touch a lot of things. Let me start from my project. If you look at it, this is my independent development environment. If you can see here in the root directory of the project, you can see that I have different modules. I have this project is configuration driven in the sense that I can tweak the parameters. If I open the config module, you can see different parameters, data source, error monitoring, forecasting monitoring. This is what you normally put if you're using in your worksheet. You normally put those parameters in your, if you're using what's it called? In your workflow, you put these parameters. For me, I've extracted them, I've kept them in a configuration file module, so I can easily tweak them. If I click on any of them, like let's say I want to go and talk about, let me say data source. Okay, for one, data source. If I click on data source, you see I have different data source of data. I have OpenBB, which is the source, data source. I have Yahoo Finance. I have Alpha Vantage. I have FinHub. I have CTrader. So I can just get a new exchange and plug it in here. So this is just plug and play. So I have the architectural design, just me to plug it, and I can give it priority. So you can see there's priority for this. FinHub is number 4, and number 1 for me is Yahoo Finance. If I change Yahoo Finance from 1 to 2, and change Alpha Vantage to 1, then it's going to pick from Alpha Vantage, not Yahoo Finance. So it is easy. It's easily to tweak. I can easily change the data source,
Okay.
and I can move it
Please,
from. Hello.
yes, please. Can you kind of zoom out a bit? Maximize your screen so that it's not very clear from my end.
Okay.
Yeah. Okay. Yeah. I think perfect. It's better now. Great.
It's better. Okay. Okay.
Yeah.
Let's take this down.
Yeah.
Okay, I'll just take this down. Right. So I have data sources. Like I said, if you look at it is modular. Okay. So there are many modules from the AI LLM stack with the Python files in there. I have the one for analysis. I have the one for back testing. If I make prediction to back test to see that it's to check for the errors between my inference and what's on ground, like your holdouts and set and your training set back testing. I have for bash runs, using bash runs because it helps me to automate the runs. I have talked about configuration and I opened the data source. There are many of the configurations there, a lot of it. I can also tweak the pipeline as well. How long does it run? How much time do you need to time out? And you can see there's a versioning for the pipeline. This will change if I upgrade. If it's going to fetch the data, how many times does it need to try? We try attempt before it fails. And I must state that this project has, for also to make sure that the data processing is fast, I have a system of caching. I cache the data in the sense that if I use the data before, it's going to stay in memory. So I don't need to search for the same data. I use the one that I was used previously to make the whole process fast. So I have data storage, the time series forecasting, caches, and so all these numbers can be tweaked as well. Signal routing, the description, the module it uses, the class, the number of attempts you need to try for it. Let's fail if it's a test run. So it's going to close that. I have a dashboard, which I'm going to show you in a moment. Dashboard for me to see. That's for like users, human users that are not technical, like data analysts. They will use the dashboard. You know, this is the back end of my project I'm showing you. So this dashboard provides front end for users. I have a data set as well. I have a database, like I said. I use the SQLite database, and let me show you the database actually. You see, there are a lot of data here. If you can see, I have the data quality snapshots. If I open it, you can see lots of data from the ticker. This is AAP. This is Microsoft. This is NVIDIA. This one is Apple. So the window, the start date, the window end date. These things were extracted. They were not here. I extracted them and I'm storing them in the database to make it persistent. So you can see the project is alive. It has the period from when it started 2025 to February 10th of 2025 to 2026 February. So it's 1 year data window for training purposes for the models to check the percentage of missing values, because you want to make sure they are missing values so that you can fill them up. You know, you can't make the data point has to be complete. So you have to come up with a way of filling them up, forward field, backward field, average field, and those are things you would have done. So so the outlier fractions, how is the data? Is it converging at the mean? So you see there are a lot of statistics here. What's the fraction of outliers? Because outliers can actually skew your data in learning process. What's the quality score of the data? For each ticker, you can see the quality score. This is 0.95, that is 95.3%. And what is the source here? Finance. If I'm using FinHub or CTrader, it's going to show source here. So this is just an example, and I have a lot of it. Like if I go back to the start and show you the date it was created to, data provenance, you need to know how old is your data in your database so you can also trade that. And you see, I have so much data points. You can see this is 37, 60. If I take it to the end, it's almost like 109 data points here. This is the database for data quality. If I go to data base metadata. I also keep the metadata for the database as well, because machines needs this information, okay, to check if this profitable proof is false, if it's synthetic, or if it's live data. So these are metadata. It is the machine, the model, the forecasting model doesn't need this type of data. But remember, there are machines in my model, in my project, that trains other model, and they need this data. They need to know if it's synthetic or if it's live, so they know how to calculate the values. They don't mix synthetic data with the live data to determine the profit. Remember, I'm in the development stage, and I need this information because this project is research driven. It's not something is magical. You can trace back the beginning of this project. You can use it for your master's thesis, which I intend to use for mine, to see how you can automate each phase of the project from the beginning to start with quantitative proof. And yeah, so this is the latency metric. I want to know how my pull through is for extracting the data. How long does it take? Because that's also a factor in trade, because we have trade in microseconds, milliseconds, have hourly trade, we have daily trade. So this latency is going to be a factor for me to determine what kind of trade I want to put. So this time in microseconds, you can see how long it takes to extract each of this data. And that is also kept. So LLM, I've disabled LLM run because it's going to slow my run. See, there are no input. If you see the data point here, 0000, you can see data point 00, nothing inside. If you go to model statistics, the models so far, you see the models have been performing on each of the ticker, the stock. You see the model that is used, GAC, Samosa, Sarimax. You can see the number of feeds it has run, inferences feeds. We've used more of Samosa than GAC. This is the IK information criteria and the Bayesian information criteria to see the quality of the inference, and then the dates also that test was conducted. So you can see how each of your models are performing. You can see it's more of GAC, Sarimax, Samosa. The multivariate singular spectral analysis reinforcement learning hasn't come on stream, so it's not here. I'm still trying to optimize that as well at the moment. And when it comes on stream, you're going to have to make some inference, and you're going to see it in the number of feeds it has made. So you can see which model is performing more or less. You can see it there. So open, high, low, close volume data. Most exchanges keep their data if you're in trade, in finance, in this format. We call it OHLCV, open, high, low, close volume. So the time when at opening, what was the price? What was the high price? What was the low price? What was the volume? And what was the closing price? This information are very important in models making prediction and in training the models to make future predictions on any of the tickers. You can see. Okay. So I'm just going to show you the header, open dates, high, low. Like I told you, that's the kind of data it has. It's very important for the model training as well. So, okay, I'm going to show you. It also keep record of your cash. How much do I start with? So I used an initial value of 25,000 US dollars. That's my start position. So you can see portfolio position as well. How many shares have I done so far? The market values of each shares. How many days has it run? So those are also tracked as well. This is my book. This is what the accountant should keep. Okay. So it's very transparent. It gives you the portfolio states as well. This is also very important, not just trading. You need to know what each portfolio is doing. Is it buying? If it's selling, you say a minus sign. Okay. Split drift metric. There are lots of metrics. These are statistical metrics on the data points for each pipeline, because you can see the dates. The date is the year, the month, the time of the dates. This is March 18th and the time that pipeline ran, and what was the cross validation, the PSI, the mean data, delta, standard delta, volatility. These are all metrics as well I use. So I'm just going to skip all this. Let me just go to some time series forecasting to see how the model is performing. You see the horizon 30 days. How did it do? Model was a single. This was combined models. They competed and two models came out with the signal that was used on the day on this February 2026, 9th of February. And you can see the statistics, upper confidence, lower confidence of the price for that ticker. And these are the model parameters that was used. And all this can be reviewed. And I've done a lot of this kind of pipeline runs. You can see the latest one is here. The latest one. Okay, these are the old ones, 2025. I've been doing since September last year, and it's the recent one in February. How much trade have we executed? You can also trace it as well to see how much. These are buy actions, sell actions, buy action, sales action. How many shares did you buy of that product? This is Microsoft. This is Nvidia. You can see at what price did you buy, at what total value, commission. I'm not just putting the price, I'm also taking consideration of the commission, because each exchange has its own commission. So that can also affect your profits. Also slippages in basis points. These are also factors you consider in trade, because you don't just trade on post platform, you must pay them. So those numbers are also included. So I see how realistic my trades are. Execution, was it live, was it synthetic? You can see this is a live trade. And the metric is what's important, not just telling you make profit. How did you make profit? I want to know. I'm very interested. Realize profits and loss on this, holding this period. So entry price, exit price, exit reason. Why did you exit? I'm asking the model. It's going to keep a record of this, and that is on my SQLite database. You can see a lot of parameters here, hyperparameters, bar close, date created. So a lot of this as well has been done. I think having said that, I think I can switch. I can switch at this point out of here. This is the data to see how that works. So you see that I have data for, this was data for the project itself, portfolio maximizer database. I have sort other data. I have data for alerts. I have data for Alloy, which helps me provide. I also log what the machine is doing and what other components the machine is doing. I have checkpoints for each of the runs. I have, I don't know if you can see my screen. I have model snapshots in case I need to reproduce the model. A model snapshot. I can click on one of them and see. So this is what the model was doing at this point. You can see the ticker. You can see the model that was used. You see the regime. It was a crisis regime. Like now in Middle East, you're having a crisis. The prices of crude oil has gone up. The price of the stock exchange also changed. So this is a crisis period. The model is going to detect it as a crisis. You can see it here. It's detecting the crisis and it's giving you the time. Okay, it's using NumPy, Panda, stats model, and the rest, SciPy for this calculation. So there's nowhere to hide. Everything is well processed. So this was the process model to see how they did process each phase of the data. This one can be looked into as well. I talked about Prometheus. These are libraries I'm using to monitor my machine as well. Prometheus is for monitoring as well, monitoring external logs. I'm not going to waste more time on that. There's one for raw data. I'm not going to waste my time much on that, so I don't bore you. I'm going to go straight into. So data. I'm going to close data, minimize it, and I'm going to go into what's called there's extraction, transform, and loading. So these are the Python code that does that. The extraction. If you want to take a look at it, I'm just going to do high level for now, so that we don't go into the details. So the extraction is done here, and when the extraction is done, you go to the signal where it is generated. The signal has to be generated as well, and the models I'm using. You see where signal is generated. Signal generator is here. Signal adapter is here. Signal router is here. You can click on the signal generator and see the lines of code. So these are docstring to help you know what it's doing, and inbuilt libraries. So you load the time series section, float values. It has to define the data points are float points and they have to be transformed. So the process of building the signal generator, you can see it's a lot of lines of code as well. And what is returns? Time series signal generator. So that is that one. For the model observability, I'm not going to talk about that one. Those are just login for me. Those are my backend logins to see what is happening behind the scene. We don't talk about that. Risk for trading, you have to have a risk. I have a risk strategy. Like I said, my models are not actually doing very well at the moment. I'm still optimizing them, but my strategy is doing very well. It has asymmetric win. It only takes trade that have a chance of winning and doesn't take trade that have a chance of losing. So that's why my models are doing badly. My strategy, which is the barbell policy, these are proprietary strategy I've built, studying, reading. I have the net asset value allocator. This one that keeps track of my portfolio. How much did I give it? How much is left? So I have the strategy side. Strategy is not computed using at what conditions does it's going to take a trade. So these are all documented. You can see the barbell constraint. This is a class. So if you're doing DevOps, you have your class, and this is the method. The bucket weight is bucketized, and trying is the win bucket, trying to lose bucket. We cannot bucketize the trades, and these are all documented. I'm going to go into that in details. Okay, now for the run, the scripts. This is where everything is run. So every other code converge here where we run them to analyze data sets. If I want to do an audit gate, capital readiness run. If I want to do something like generate synthetic data set, this is where it's being run from the roots of the project. Yeah, I'm going to do some run in between as we go on. There are a lot of scripts to run. Even the OpenClaw LLM also uses this Python code you can see here to run. Primary Model Exchange also uses it as well. So there's a lot of runs I do here. If I want to run the entire pipeline, I run it from the bash script. I can do a quick run. See, let me just see how that goes. So if I want to run this pipeline, ETL pipeline, I can just say, if you can see my terminal here, make left and see clear. It's a Python. I'm not using my, most people use Windows support for line. I'm using the Windows terminal, my Bash terminal, my Windows, I'm not using a Linux terminal, I'm using the Windows terminal. My Bash terminal, which will run on Linux, is down at the moment. So I have to make do of this at the moment. So I can just go to scripts. I don't want to do check classify. I'm just go script and say run ETL, run ETL, run ETL pipeline. So I've done that. It's running. If you can see on your screen, it's running. The pipeline is extracting live. It's going to transform the data into a shape the models can use. Then it's going to load it on the model and also save it in database when it runs. If you can see my screen, this run now is a pipeline run, and you can see the first model salary max is now auto-regressing into integrated moving average with exogenous futures is running. It takes time because this is a spectral model. It has seasonality, like seasons of the year. It has auto-regression for the idiosyncrasies of the data. It has moving averages to average out the data point, and it also have exogenous factors like either the crisis or war or sentiment. And it takes time. This is going to take a couple of time. And you can see when it's running, this is 2026, April 4th, 1647 is running live. While it's running, I'm going to give it some time. I'm just going to continue with the project while it runs. Okay. I also have some PowerShell script to run on Windows as well. So this is running on a terminal. So I can close this module that has to do with script. Script is a module. So you see the script that is running at the moment. This is just one script, run ETL pipeline, and is running. And you can see the code, the Python code. This project is 95% Python, maybe. In the future, I can transform it into C to make it faster, to take out the Python overhead. So for now, it's in Python. You can see I have to call ETL.data source for the DevOps guy. So ETL.data source. This is a class, and I have to import data source manager from other modules. You can see how I call them. I've also from this ETL.data validator, I imported the class data validator. I did so for pre-processing, data storage, checkpoint managers, pipeline logger. And you can see the classes that are being imported here. And since they have Olama integrated to also do his own check and run, it's also integrated in this run ETLs. The system is built in such a way that it can also self-train itself using the LLMs. I have DeepSeek 18 billion parameters as an LLM inbuilt. I have Quen 3B, which is a local model to help me with tooling and orchestration. So I can build myself, and my LLMs locally can also build, and they can also call runs. But for now, I've disabled that feature. This is to enable me do the building. When it gets to a certain stage, I'm going to integrate the LLMs for daily runs and also for improvements and also for analysis. So yeah. So if you can see, there are different methods. There's execution modes, auto, live, synthetic. It can be automatic, it can be live, it can be synthetic. Live, like what I'm running now, is a live run. Okay, live is by default. Set up the login. Login for me is very important. I want to know what the model is doing because I need to debug it. I need to know if it's where, because it's very important for you to have your logs. I'm going to show you my logs, how voluminous it is, because if you don't have your logs well crafted, then you don't know how to debug. And even if you want to make use of smart LLMs, they don't know what to do. So this project can self-iterate and build on itself because I have the logs of what it has done in the past. Good enough, I have about 5 terabytes of ROM in my system, so I can store those logs. So I can also detect the device. If you're using a CPU or GPU, I have a GPU locally. I can be remotely. I can use my CPU as well. So it has a method to detect that as well. So you know what to use around. It has a fallback, safe fallback failure system. And that is just for one run ETL pipeline. This kind of architecture is similar for others. So I'm not going to bore you with that. You can see that the run ETL has made some progress. It's still on the Cyrimax because Cyrimax is really heavy in the way it is designed. It has to do some transformation. Then it has to um, make sure that the data points are within the unit circle. Otherwise, it's going to explode. So it's a very complex model. I don't know if you guys have played with it, Cyrimax model. And why it is used because it is fast, but it is fast compared to other models. But the Samosa is much better. It's much better than Cyrimax. But end of the day, they will all compete among themselves to see which one outcome gives a better outcome in terms of when you predict and we make a buy, what's the outcome? So this run has completed. And if you can see, okay, the pipeline completed successfully. The execution mode is auto. It's not live. It's auto. You can see here. And the pipeline is here. I can go to the logs later to check what was in the pipeline. This run was kept in logs.automation.database here. So we can go there and see. Let us go to logs. There's log, 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 log. Okay, this is log. We'll go to automation, automation. Okay, under automation, we go to database provenance. Database provenance for 26, 4th of April. So this one is 2025. I'm going to scroll down a little bit. It's 2026 second. I'm looking for 4th, so we're going to go down a little bit further. So this is it. I think this is it. So this is 1647. So data providence 1647. I think it's the saving. Okay. Pipeline. Okay. Let's go down. If you are there, 2026. The point is that for each run, you can see what happens. You can see it. Okay, see it here. I think this is it. Yeah, this is it. If I click on it, it opens on my screen. I can see it here. What has happened? Origin mixed. The type of data OHLCV, open, high, low, close volume. Source Yahoo Finance, trade source synthetic is Yahoo Finance, and the data set IDs for each data point. Profitability proof is the run show profitability, say false, it's not profitable. Why? Because it's synthetic data. Okay. Execution mode is auto, is automated, no human in the loop. Data source is Yahoo Finance. So you can see the metadata of this run, and those as it captured here. So yeah. Okay. So I think having said that, I'll go to the, let me do one more thing. This project is also live on GitHub, and I don't know if you're there. If I,
Yeah, I
if
think
I,
it's there. Let
I
me share it, the link again.
okay,
For those who let me share.
it's live on GitHub. So I'm just going to share the screen, my GitHub screen for you to see, because I'm going to do a run now, and you see how it's going to reflect. So any run I do also reflects in GitHub. It updates. It also have GitHub action to check if there's any issues. So if I, for instance, make a change, I go to the if I go to the configuration module config. Let's say I want to change the data source. I could change the parameters of the model as well. Okay, there's one for model profile. So each of the model now has its own window length, parameters, inbuilt parameter, maximum P, that's to read the season, the D, the differentiation, is it differentiated into by order of one, and the Q, which is the regression, is regress by order of 2. This I will not change because this can actually affect the outcome. You can see the rank of the model. This is 4. I can change any of this. Okay, let me just do the one I saved. Let me see data source. Using Yahoo Finance. I can change the one finance FinHub is priority number 4. I can make it priority number 3. Make priority number 3.
Okay, just to inject here, for those who might be watching this on YouTube, the link to the repo will be shared in the discussion channel, the discussion section of the YouTube channel. So for those who might be watching on YouTube, you can check the description section for the repo link. Yep.
Okay. So I've done small change. I've upgraded FinHub up to priority number 3, and I've downgraded C3 as priority number 4 as a source of my data, just to keep it safe. I'll save that. I'll close it, and I can just check my Git status. To say Git status, Git status, Git status. Okay. And you see that there's some dirty work here. There is a modification to the configuration file I just changed. I can add that and say git add. I say git add config / data source. Okay, I can add it. So that's added. So if I do now git I've added it. I can do git commit. So I can just say I've downgraded git commit. I've downgraded commit. I've downgraded which one did I downgrade? I downgraded FinHub. I upgraded FinHub. So I upgraded FinHub. This is just for tracking. Upgraded FinHub to priority 3. So this process happens anytime I change my code. I have to commit. So that is committed. Then I have to do what they call git push origin master. So once I push it now, I'll change my screen so that you can see that it's pushing. It's pushed to master. Then I'll change my screen to my other repo share screen. Just a minute so you can see. Let's share screen. Let me share the screen for you. All right. If you the screen's a bit busy, you can just open it GitHub. If I go to my GitHub and go to actions, GitHub actions, GitHub actions, which track says is running. So my GitHub action is running to check my updates. It's going to check for if there's the changes I've made, if there's any dependency issues, it's going to highlight it, and it's going to check if it's been pushed to the master, if there's any conflict as well. So it's make sure that I have this continuous integration and continuous development integrity as well. So I can see the failures, I can see what needs to be adjusted from GitHub. So when this whole check work action, GitHub action is completed, it's going to show whether it's green or red. So you can come back to that. So it's not just building your pipeline. You have to make sure that it's running, it's healthy, and you have layers of checks as well. So that's for that. So that is running. If you can see my screen, I'm going to go to the dashboard. If you look down here, bottom left, you see my project screen. So this is the dashboard I was talking about. I don't know if I should zoom out. Let me zoom out. Let me make it big. Can you see? So can you see it? Can you see it, please? Okay, you can see it.
Yeah.
So
yeah.
You can see I have audit gates.
Yeah.
let me know that. So I have some metrics that I want to check if the project has passed. See, it's failing at this point. It's making profit, but it hasn't reached my standard of metrics I wanted. And this audit keeps refreshing itself. This is in second. And I have some work to do on the profit side. This is a live dashboard, so you need to have some work to do. You can see some visualization. This is also in the code. I can get better visualization from the repo as well. Let me go to, I'll get back to the repo on the visualization to see what we are doing. For now, I'm using Prometheus to monitor. This is my Prometheus dashboard. I'm using OpenClaw. If you look here, you can see my OpenClaw gate. It's live. Telegram is live. It's running 7 hours. This is 4 hours ago. It's running. Gives me updates. What's happening? This is my OpenClaw. And the OpenClaw also help me with orchestration. So, and this is the back-end terminal of the OpenClaw. This is what you're seeing here, back-end. And to check if the channels are alive, if they are feeling network issues, I get to know. So I don't leave anything to chance. Back-end, front-end, terminal runs, windows of other libraries I also check as well. So let me switch screen to the other visualization so you can see. Okay, I'll just see if I can see the visualization. Just to show you the visualization to let you know that there are many layers of checks. In the visualization, I have diagnostics, I have assembly diagnostics, I have performance, I have for each ticker analysis as well. So if I open a ticker now, you can see this is the parts of the ticker seen when plotted. This is for Apple stocks, and you can zoom in and drag. You can zoom in to see that the 3 models. You can see actual and the weights for the models aggregated weight. It's here in this instance is GAC model gave a weight of 90, while Samosa gave a weight of 10. So GAC did a better job. It was much weighted. I can go into diagnostics and see. You see the diagnostics. On top of directional accuracy in terms of the models for each of the tickers. How did they perform? The tickers against the. Let me make it big so you guys can see. Expected returns on average, win rates on average, the spread of win rate. I'm taking statistics for the win rate. I'm taking statistics for the shape ratio just to with the accuracy on the shape ratio. Metrics correlation. How are they correlated? This is the heat map. I'm sure you're familiar with this confusion matrix. So if you zoom in, let me zoom in and see. What's the profit factor in relation to the annual return, in relation to the shape ratio, in relation to the Sentinel ratio, drawdown, volatility? These are all metrics, win rate. I cannot put them against each other to see where the issues are. This is red, you can see. You want to see how when the profit is high, you see that there's profit and profits correlated is 1-to-1. So how does win rate correlate to profit? Win rate to profit is minus 0.2. So the win rate to profit is not correlated from this analysis. The volatility to the profit has a ratio of 30%. So this one is inversely correlated, right? This one they are related. So when the profit factor, when the volatility is high, you see that the profit factor of 30%. The profit is influenced by the volatility. So you can see how this factor influence each other. This is drawdown to the profit factor. I can do it to the win rate as well. I can do it to the volatility. So you can see the relationship of even the annual returns to itself is 1, but the annual returns to the profit factor is not related. So you can say that the annual returns to the profit factor this machine is designed for short trading. It's not for a long time. You see, it's negative correlated, 97% negative. So it shows you that this is something that you want to do for a short time. The trader I'm doing actually is for 30 days. It's not for annual. So I'm not holding them for a long time. I'm holding them for 30 days, and the message shows you that it's correct. Okay. So that's for diagnostics. I can go into assembly metrics. I can check assembly, how is it performing relative to each other. This is taking some time to open. To give it some time, I can go into performance and see performance, global war. How does this is look at this? This is interesting. Global win rate, global win rate over time. The win rate over time for different tickers has it gone? Trade index, cumulative win rate. It has started low from zero, it went up, came down, went up. So I can actually say, okay, why is this thing going down? How is it modified? How is this project performing over time? It says going down because I've been doing some big lifting and the win rate has gone down. And I have to track that and make sure it gets up back. Okay, and that is something that is visualizable. Um, Global lift against recent lifts. You know this plot. Um, um, so this is instances you use visualization, particle win rates. You want to see how each ticker is Apple, Google stocks, Microsoft, Nvidia, how they're performing. So you know what, my machine has a strategy. So those that are giving me poor win like Apple, you're going to trade away. It's not going to trade on Apple because it's giving it poor performance. So win rate, profit factor. Profit factor is, I mean, for every naira, over the amount of money you put, how much does it scale to the factor? So it's visualizable. You can see it on a scale of 5. So these are all metrics that as is produced. I'll talk about quantitative validation, which determine which the signals to use. So for Apple stock, you can see the moving average over 20 moving average because the machine will take the moving average and make a prediction. This dotted line is mostly what the machine is going to use to predict the models for star remarks. So we're going to look at it. How does it relate to the actual closing number? When they cross each other, that's when it is 100% correlated, and that is 100% accuracy. And when they are far apart from each other, this is a big error, like on this date. So you can see I said for 2023 and I ran it back to 2025. That's for Apple. I do the same thing for AMD stocks, for Amazon stocks, for Google stocks. The machine, this is, you can see how it's performing on each of these ticker. You can see that it's just averaging out. It's very rough, and that is why I have to use a combination of different models because it's sometimes it gets it. See, September 2025, it's kind of edgy. It's so unpredictable. It goes up here and it's down the next time, and you can see my model how it's performing on that. So I think that explains most of it on the visualization as part of your way to diagnose how it's performing. Of course, for DevOps, you want to have your .environment. If you look at my mouse, your environment variables where you protect that. You're not going to commit this because this have all my environmental variables, my password, my keys to all the platforms, GitHub, finance, all the things are saved here. So I'm not going to show you this. It's not going to commit it. So be careful. Make sure you put it in your Git ignore. Your Git ignore. You see my Git ignore has those .environment file as ignored. Make sure you don't commit it. If not, they're going to put it into your system. So these are one of the security measures you're going to put. These are my Git ignore, what should not be committed. This is not everything here is not going to be on GitHub. If you fork my repo, you're not going to fork this up. So this is what makes me unique. I can take, and now the repo is open. In the future, it's going to be closed. So for now, you have, this is more like initial public offer I'm giving. In the coming months, I'm going to close it, make it private. So if you want to fork, you can fork in time. If you want to collaborate, to be a partner, you can collaborate, then we can work for that in the future. Otherwise, when it goes closed, then you can't see it anymore. Okay, I think haven't said that. I think fairly enough, I will go back to my slideshow. Go back to my slideshow. Okay. Slideshow. I'm going to continue with the slideshow, and I'll say I've shown you a version. So for me, the speed is important. I have GPU locally. I'm not running the cloud because I want proprietary access. I'm trying to keep my costs low. I know I'm a solo developer. I can't be using cloud compute. I'm paying runtime and inference time. So I got my own GPU, GPU, local GPU, RTX, NVIDIA systems that run these systems for me. So I'm saving cost. I can experiment. I don't have any cost of inference like Google Colab or Amazon runtimes and Google runtimes. I'm using my own locally, so that's for that to save cost. Until when it becomes profitable, I want to scale and make it more fast. I can take it to the cloud when the profit factor is. So you have to make business decision as well. Okay, business decision. So question and answer, the floor is open. Over to you, Mr. Eric. Thank you.
Okay. Wow. 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 After presenting all this, I feel like, the amount of time that we gave you for this project, is very short, right? Yes, I feel like this
Yeah,
project, it can take us like maybe like a whole day, because imagine taking us through those lines of code, having to explain to thousands of like hundreds of thousands of code, right? That's a
yeah,
lot. Yeah, and also the important thing, one thing I got to is that it's an end-to-end project, right?
yeah,
Yeah, it's an end-to-end project, which makes it a fully, you know, production grade project for anybody, who, if you want to take it as your own personal project to also learn, right? Or maybe for your own research, I think this is a good fit.
yeah,
And also, if you want to take it maybe for to upskill yourself, to upgrade your CV, and get into the job market, I think this is also perfect fit, right? So
yeah,
for me, actually, I've learned a lot. I've learned a lot to see the integration of data in it, to see the integration of ML, see the integration of AI itself, and then cloud and DevOps. Like everything is just intertwining between, throughout the entire project, which I actually love it. Actually love it. Yeah. So before I ask my own question, I want to ask, okay, let me go to the participant. I think Dr. Anthony has a question. Yes, Dr. Tony.
Yes, good evening, everyone. It's evening here in Nigeria. Please, can you hear me?
Yes, yes,
yeah. I
100.
can hear you.
Awesome. My name is Anthony Anyao. I'm from Nigeria. I'm an AI software engineer and as well a data scientist. Yeah, that's in tech. So, yeah, by the way, Mr. Mayoga, thank you so much for the wonderful session. In fact, this is
Thank you.
this is a product. I
It
don't
was
call it a
funny.
project. This one I greet you. See,
Yeah,
this I don't call it a. If you are, there are things we call projects. This one is product. Is technology.
yeah,
Technology.
it is.
Because
Yeah,
it's end to end, it's full stack. This is the kind of things I love to build. And I've been, because of the nature of things I do, I've also been able to work with some of the stacks that you use. So when we are going through some of the things, I was like, oh, although some of them are still advanced for me. You see, that's why I call you my Oga. So, but by the way, this is very, very fantastic. So yes, sir. So my question is, because my question number one is on OpenClaw, because I intend to work on a project with OpenClaw. I've been watching it for some time now. So my question is, your OpenClaw, where did you host it? Is it on your machine that is locally, or is it on a VPS that is virtual private server? Is it on a server? Because why I'm asking that, of course, OpenClaw, released by Peter, there are security concerns when they say that there are security concerns when you run it locally, that's on your machine and all of that. So I would like to know where you hosted yours. Then secondly, I would also like you to talk a little bit about, you've told me about modular programming, by the time I came to your place. So maybe you just touch a little bit on modular programming as well, so that I fully grasp the concept. Thank you very much.
okay. Okay, so I should answer. I will just go answer straight on. So OpenClaw for me, it's an orchestrator. Um, I have a lot of clone jobs. If you look at my screen, yeah, it's OpenClaw dashboard. If you can see it, If I go to the cron jobs, you can see a lot of cron jobs. It checks my system health, which I should pay someone to do. It does the model training for me. It does the profit and loss integrity audit to make sure that is correct, which I'm still working on. Nightly training. It trains at night when I'm sleeping. It also labels my JavaScript object notation lines, labeling to make sure the models get what is labeled. There's a lot of work lifting for it, gate lifting readiness, because I have gate checks to make sure that I don't just proceed without making sure each gate, each metric is met. Classify, retrain. It triggers retrain for the model in case there's a shift in regime. The model sometimes when the model is trained, I can use that model to make inference in real time and can avoid there's a shift in, like now there's a fight in Iraq and everything has changed. The price of things have changed, so the conditions of the market has changed, and that's a critical shift. It does kind of orchestrate that for me as well. It doesn't do it. It is a tool that can call the models I have, the forecaster models I have. So there's a weekly session cleanup, there's a count validation, there's a production gateway check, signal leakage monitor, ticker health. So there's a lot of stuff. Okay, back to your question. OpenClaw, yes, it's giving me stress because it has some security vulnerabilities, and they would encourage you to use APIs of GitHub or Cloud, especially Cloud API or Cloud models integrated into it as its native LLM, because OpenClaw is just a gateway. It's a library that enables you to use a gateway to communicate remotely with other devices. Then it calls the LLM, maybe Cloud LLM, to make the inference, to make decision. Then use the tools that the OpenClaw can use. So I'm using it locally, and it's one of the security challenges I have at this time. I might disable it. For now, I'm not using Claude because Claude has been disabled OpenClaw. I'm using deep call it Queen 3 that has tooling in the sense that it's not just making inference. You can call web tools, you can call calculator, you can call other models. It's a model that can call other models, so it has tooling capabilities. Then I use DeepSeek 18 billion parameters as the thinking model. So OpenClaw for me is integrated with Qwen 3B tooling model and DeepSeek 3. So it's a lot of orchestration here. So OpenClaw itself is a smart system library. It calls other models, which now with the combination I can use to now run my project, to run the forecaster, and call the Python script to do the ETL runs and the rest. So that's for OpenClaw. The security concern is there. I will look into it later. For now, let me optimize my project and make it profitable. Then those other ones can be sorted out. I can either disable it altogether or use a paid version. For now, I'm trying to keep the costs low. Like I say, this is not a project. This is a business. I keep the project low so that I stay within profits. This is a lifetime project. This is on GitHub. My children, my grandchildren are going to grow up and live to see this. They can continue building on this in 30 years' time because it's running live. Like I show you, it's live, it's persistent, and you can fork it, you can do whatever you want to do with it. So you can see, if I show you my GitHub here, you see that the GitHub action is complete. So there are no issues with automatic dependency. It's run 20 minutes ago, it's complete. I just pushed a change and the push is on master and it's clean. This upgraded string up to priority number 3 is having some issues which I'll look at much later. Minor issues. So it's live. It's running live for my system, my machine locally. I'm using other libraries, and it has a dashboard for newbies that love to see the beautiful things. You see, there's a portfolio maximizer dashboard for the data analysts. Those guys just joining up that don't like seeing code, that could be scared. Then it has something to help you with that, and yeah. And that's it. You can see my local stack here. I have a GPU. I'm not just making it. I don't just run it. I own my system, my project. So I want to own it. I want to have proprietary control over it. So I'm not just doing software. I'm also doing hardware. You see the NVIDIA GeForce RTX 4060 Ti. So it provides. You can see the GPU usage here. I don't know if you can see it. You can see if I start running, it goes high, it increases. And all these are all things you need to consider when you're making a project. If you're using virtual systems, cloud, then you don't need to consider it because they'll provide you those stuff, but you have to pay for it anyway. So you have to look at the business decisions, trade-off. Not just good enough to do a project. If you want to do a project that works in real life, there are a lot of decisions to make. So your second question, you talk about modular system.
Sorry.
Okay, for yes,
Excuse me. Yes, big man.
yes,
So talking about OpenClaw, right? I'm glad you mentioned that it runs locally. You're running locally. For people that don't know, OpenClaw is basically like, although it was just newly released, instead of like normal ChatGPT that we do, you ask ChatGPT question, it gives you an answer.
yeah, I
For
can talk in chat.
OpenClaw, you set it up, yes, and it goes and run an errand for you, like while you're sleeping or while you're doing some other things on his phone. So yeah, back to what we were talking about. So for the security concerns, so people are saying, the security concerns, because it's an advanced agentic AI system or technology. If you're not careful, it can even steal, and because they're running locally, it can even steal files and data from your computer, from your machine, and expose it out there. For instance, some of those things that you have in your .env file, some of those API keys or whatever, or some
Yeah.
sensitive data in your system,
You, you,
you
you,
can steal it and
Sorry, let me just cut you short before you continue. If you look at my system bottom right, you see that I asked the OpenClaw what is the status of my top right. I asked the OpenClaw what is the status of my project, and it had to run. It made a run, and if you look at the bottom right, you see that my GPU usage has increased. If you can see it, I don't know if you are seeing it. It increased because OpenClaw actually called the tool. So you see this colored portion, yeah, is the usage that's increased because the OpenClaw called my system, called the GPU, and I can see, and I can track the OpenClaw security issues to see if anyone is touching or reading my. I can do a unit test and add in my security for that. I can encrypt it from the .env. The other encryption, you can encrypt it so that even the OpenClaw cannot see it. You cannot just see it like raw text. So if you want to steal it, I can encrypt it and make the encryption out of my system, keep it in the cloud. So those are things I'll do in the future to harden it. I'll smart the OpenClaw. With every problem comes solution. It's working. You see, it actually says the project status shows the WhatsApp gateway is connected with one active session. Cron job 10, profit and loss is what he gave me as at this date. He says using authentication provider, Anthropic, Olama, and Queen Portal. So it's working, and you can see, I can come and say, what's happening? My system has increased. The OpenClaw is running. Did it run? I have metrics and log to check what is running and what was exchanged. You can see the telemetry for the OpenClaw. I also have the telemetry for the OpenClaw to check what is sending. I think I showed you the other time the telemetry for the OpenClaw. I showed somewhere. I kind of check the telemetry for OpenClaw as well. Just a minute. Just to be sure. See it. Bottom right. See it. I can also look at what it's doing and what is. I can check it behind. I can debug it as well. So okay, back to you, Tony.
Yeah, awesome. I love the fact that you are doing all of these things. And this is a technical session, and for some of us that who may not be able to, put in these checks and guardrails, just to add as well. So going back to OpenClaw, so some people they are suggesting, experts are suggesting, you can run it on a VPS, that is virtual private server. That is in the cloud. That is basically a cloud or a computer in the cloud that you just rent and all of that. Then also this guy, NVIDIA, they released a technology around OpenClaw called NemoClaw, still all about security and setting guardrails in OpenClaw. So I think these are also some of the, because of the security concerns in OpenClaw, these are some of the ways somebody can work around it. But I like what you are doing so far. I mean, it's very, very incredible, and I commend you so much.
Let me add. Thank you for your input. Then security concern. Who is an expert? I'm an expert. I'm not just talking. I'm doing it. So expert is experts. They are expert solutions and they are proprietary solutions. And what gives you an edge is that niche implementation you can do what nobody has done, and that is the edge you have. If you're doing what everybody is doing, then you just remember they also put in the cloud virtual private server. The people that provide these virtual services, they want you to use their services. They have so much compute. They want to use it. So every solution, they're going to create a solution that is always going to be favorable to them. Me, I'm in Africa, I'm in Nigeria, I'm in Nigeria. I don't have the money. So you have to look at what is your business proposition. Do you have the money to do that? If you don't have the money, then your brain must work. You must come up with proprietary solutions. So I'm not going to put, yeah, the virtual private server is okay, but you're going to have put virtual private server is where the server kept someone's house. My system here can be your server. I can host a virtual private server for you, and you will know I'm not hosting it. So you are exposing yourself, putting yourself in virtual private server. I'm doing here business here, and it's money involved. This thing is going to go into trillions of dollars, and I can't just put in a virtual private server that's going to run it for me and determine my fate. I'm going to keep everything local and maybe have a hybrid system in the future. Those things are not too very sensitive. I can put them out there. Then I'm going to do a trade-off between easy system. I might take out OpenCloud totally in the future if I see that I don't need it because I have people working for me. For now, I have nobody working for me, so I have to use OpenCloud to do my job. And if it's working better than anybody, if it gives me too much stress, I figure out get somebody to do the job. All right. Over to you. I don't know if that answers the question.
Yes, it does. It does. Then the modular programming.
For the modular, okay, I have to share my screen so you can see that in real time. For the modular, okay, it's fine. So if you look at my screen, I have the root directory, and why it's important to do modular so that each module, like this AI stack, now AI LLM is a module, has several Python files, and just what I need to make it a Python module is just this init. When you do done underscore init.py, that module can be callable. So this is what you, of course, you will learn when you do DevOps. This makes it callable, and this is a init file. I've opened it, and other files inside there like LM activity loggers. I can do an OpenClaw activity logger to here to log OpenClaw and know if it's stealing my MV, if it's stealing my credentials. I will do a logger for it in the future, and if it steals it, it's going to show what it has done because I will track it. So I'm going to keep it on that thing. So the module system makes each module callable. It makes you can do this plug like a Lego. You can plug in something, you can unplug it. I can unplug the airflow. Like now, this airflow, I'm not using it. This direct acyclic graph, I'm not using it. I'm not saying using airflow. I did the initial implementation, then I stopped. You see this airflow, DAG, it has ETL, blah, blah, blah. I didn't use it. I may not use it, but I just did it initially and I've just dumped it there. It's just redundant at the moment because it's modular. There's an analysis module, there's a backtesting module. So the modular is the sense that you don't just, this is a monolithic project. I'm not using microservices. It's monolithic. So everything is stacked in one root file. But I break it into small modules. I create a file. A file is just a module. A folder is just a module that has, if it's runnable, then it has dot underscore in it. That makes it a module. It's just a folder. Okay. If I show you from here, so you see. Let me show you from a layman perspective. Maybe a layman perspective might make it clearer. If you see here, you go to my project. Here, project. You see the models. They're all just files. They're just files here. So this is the one for. I showed you this script. What was that opening before? This one. If you go to this place, let's say backtesting. Under backtesting, if I open this, backtesting. See backtesting here. You see, it has a pipe catch. Is the fact that I have done a underscore init.py, it catches it, so there's a cache for it. So these are the files, Python files inside there. And it's nothing more than this, just keeping it in different modes. So you can delete one, unplug one, they're all connected to each other, they call each other. So the scripts here, the script model, you can call any other model because it's being instantiated. So if I look at it from the IDE, it looks different here. And yeah, the modular system makes it, to help my LM, I have lots of markdown files. I can trace back what I've done in the past. So the modular system, even the logs. Okay, go to the log. Let me show you the log. Good. Let me show you the log. Audit gates, automation runs, Docker files, assembly health, errors, event, evidence replay, forecast audit, cache, LLM activities. I can put an OpenClaw activities here, which will track whatever OpenClaw is doing. So like this is just example LLM activities. You can see what it's doing here. I have a OpenClaw. This is OpenClaw too. I also have OpenClaw as well. So, okay, this is what it's done. I can make it more rich to track for. So OpenClaw is actually running to check profit for me as well. So it's not just the Cybermask models that are running. I have time series models. I have LLM also running. So the LLM is just like the benchmark. It's not going to perform as good as the other one. So future iterations, I will do that. So I have something on what the LLM is doing when it starts, when it ends. So the LLM's activity is also logged, and the OpenClaw is one of such. So you see that it's modular, and inside the log, this is the log. If you open the log, it has children. These are all the children. OpenClaw activity, OpenClaw notifier is there. What did it notify? Error. No active WhatsApp. When did it do that? It did that in February. So I can see what he's doing as well. It's not just I'm not leaving it to run freely. I'm tracking his activity. I'm ultra auditing everything. I track overnight runs. So these are JSON script object notation lines. They are very long. These ones are consumed by models. They are consumed by smart models. They are not just JSON. They are JSON script object lines. So they are also containing key value pairs like that. You see, so these are blobs. Okay. Performance metrics is also logged. Run audit. Each run I run, there's an audit for it. These I will audit in the future more precisely. I have other higher goals I'm trying to do at the moment. So each signal they generated to count validation. How was it validated? You see, it's a large signal with timestamps, signal ID, pipeline ID, run ID, confidence, expected returns. They're all logged numerically, volatility values, failed criteria, visualization, count validation, Microsoft, the ticker, what you traded on, profit factor. Is a lot. I can't even take it to the end. Assembly is a lot. So logging helps you to monitor what you're doing behind the scenes, and this is just one of. There's also stages. I also log for each stage as well. Yeah, and that is it. I don't know if that answers your question just briefly, or you have
Yeah,
something to add.
thank you. Thank you so much. Thank you. Do you know what I can say from all these things that the modular programming and even the open clothing? What I will say is, I think you are, because you're a big boy in coding and software engineering and all of this, you are doing the security checks and all of that yourself, like yourself. Unlike us that are trying to leverage the abstractions that VPS will do for us, that NemoClaw will do for us, that the one from Cisco will do for us for the whole OpenClaw thing. I mean, you are putting in these checks already, this security and all of that. And coupled with the fact that you are running this on your own GPU, I mean, that is so incredible. So, yeah, I mean, thank you very, very much, and kudos to you.
Oh, thank you very much. I want to keep it within the budget, which I want to keep it secure. I have a security background. It's not just building an application. I want to make it safe. You want to keep the cost within reach. You want to see for learning purpose too. You want to learn every bit of it, from hardware to software to orchestration to libraries to logs. That's what makes you full stack. So I can tweak any aspect of it. I can outsource it. But outsourcing it there, you've not learned that. So where you learn this from the first principles, from the mathematics, I look at the mathematics, how each data point is transformed. Is it log transformed? Is it averaged out? Those details are very important. Those micro details. It's not just typing codes. You have to transform each problem to mathematical problem. Then you're going to write it in code. Then you're going to determine the architecture to use. You're going to use monolithic microservices. You want to keep it logged. You want to keep it tracked. You want to have checks, fail safe checks, quantitative checks, and stuff like that. And it's good to see this back to back. And subsequently, I can go on a lighter version of this. So I don't need to log everything. Maybe I can put the logs in the cloud. If I want to use the cloud service in the future, I can put logs in the cloud. I can put the maybe onboarding of customers in the cloud, but the main engines will be locally. Yeah, keep it safe. All right, over to you. All right.
Okay. Well, this is interesting. It's a long conversation, right? We can stay here and then we'll be discussing back and forth. I really enjoyed it. I really enjoyed it. So so we've come to the end of the session, right? And for those who are going to watch this session on YouTube, I'm going to share our community link so that you can join us, follow us on LinkedIn, join our WhatsApp community, and you can also follow us on Facebook, right? So let me drop our community pages so that you can follow us. So again, this is a Saturday workshop session, and today we had Bestman. And an interesting thing too about Bestman is that he also did his studies, completed his program from Solaris Tech, right? And now he's kind of giving back to the
Yeah.
community, and it's really a big opportunity. And we are so grateful, Bestman. We don't take it for granted, right? And we want to plead with you again that if there are more interesting projects, right, the ones that can be good for our students, right? I know this is not a project. This is like this is a lifetime program, right? So it can have projects for that are most drop.
I think your voice is out. Sorry. The audio
Yeah.
is out.
It's,
Now.
So I must also state that Solo Bisec has been very impactful to me, shaped me one or two ages. And I think subsequently I can just drill into just one model. I think one module rather is enough for this presentation. If I go into forecasting model, like I can do forecasting or just the data set extraction ETL, because for new starters in Solar Vitex, this might be a bit complex. But I had to give this high level overview today. Maybe subsequently I'll just drill into just one module. I can just maybe just say, let's talk about time forecasters and just drill into it, the details of time forecasters, not just the logs. And in time forecasters, that could provide insight because we can now deal with the code, each code. In time forecaster, just work with one or two files in it, and that will be fine. But this for me now is kind of high level. I don't know, make it a bit detailed to challenge other people to say it's doable. I have an arts background. I work with the government. If I was doing this full time, probably I would have finished this project by now. But I have to go to work 8 o'clock to 9 o'clock at night, and I use the money to do this on the weekend. This is a weekend project, and you see how complex it is. So it tells you can do much more if you have the time. And those guys don't have the time, please make the best of it. Thank you.
Yeah. So let me drop our community pages. Let me drop it. Just a second. Okay, it's coming up. Okay. Great. Okay, so so thank you so much, everyone. So next in our program, we are going to have, following this, we are going to have a podcast session that will be coming up in 2 weeks for those who haven't joined on the specific topic, right? So we can't wait to have you in our next program, and enjoy and have an amazing Easter weekend. Thank you, everyone. Thank you so much, Mr. Bestman. Thank you, Dr. Tony. Thank you,
Thank you
Kenneth.
for having
Thank you,
me,
Sam.
and please share the links.
Sure. For sure.
Thank you.
All right. Bye, everyone.
Bye. Bye.
Bye. Yeah.